Welcome back, reinforcement learning. The second unit, second topic, predicting future rewards by using value and policy functions. In reinforcement learning, the main objective of reinforcement learning is to get the maximum cumulative rewards. Okay, how to get the maximum cumulative rewards? We have to predict the best rewards. We how to predict the best rewards by using different functions. In this lecture, I explained the value functions and policy functions we are using to predict the future rewards. Okay, in general process of reinforcement learning algorithm is an agent. It is interact with the environment. Agent interact with the environment with the actions. The actions changes the environment particular state into another state, and the environment also produce the rewards to the agents. Okay, when agent apply some action on the environment, the situation or the state of the environment is changed into some another state. The state transition, the probability of state transition is called the probability of state transition means the one state to another state transition. The probability of state mapping from one state to another state is called a transition probability. In this transition probability, it produces the rewards, not actions. So in general process of reinforcement, agent apply the action on environment on particular state. The environment produces the new state and rewards to the agent. This is the general process. In reinforcement learning algorithm, agent must predict the best rewards to get the best cumulative rewards. In order to get the best rewards, we are using different functions to predict the future rewards. The one of the function to predict the future rewards is policy function. The policy function is the mapping function or strategy for the states and action. It maps the states and actions that indicates what actions the agent should take in a given state to get the best rewards. The policy function is the mapping function to the states and actions. These policy functions are either deterministic policy function or stochastic policy function. In deterministic policy functions, it always return the same action for the state. It always return the same action for the state. Stochastic policy returns the probability distribution or actions for each state. Okay, for example, the policy function indicates the pi of the state S, the probability distribution of action on the state S. The policy pi is the mapping from states to the best action for those states. Okay, these actions are probabilistically best action for those states. Okay, here the example in simple grid world example, the policy function might map each grid cell to a probability distribution over the possible actions. The grid cell is the state. The possible actions are move up, move down, left and right. In this for some instance, the policy function pi of the state move right, the action cell 1 is 0.7. The policy of the state move up cell 1, the position cell 1 is 0.3. The policy move down at the cell 1 is 0. So here state action mapping. Here the actions are different probabilities. The move right is 0.7, move up is 0.3, move down is 0. They are different probabilistical values. 70% chance for moving right, 30% chance of moving up, and no chances for moving down. This is the probability distribution of the actions on particular state. And one more example for the policy function. Dictate that if the agent knight in the chess game, agent knight is under threat, in that situation it should move the knight to the safe square. That is the policy function. It is a deterministic policy, it has only one option. Stochastic policy, it has the several options with the different probabilities. In deterministic policy, it will always move the knight to the same safe square. And stochastic policy, it might choose the between a few safe squares available, several safe squares with the different probabilities. And one more example, the grid world example. where an agent can move up, down and left or right or down. Some policy function could be the deterministic policy. It is only one option. For example, the state is 2, 3. It always moved right to 2, 4 only. In stochastic policy, it has multiple options. The agent is in a state 2, 3. It moves right, the probability is 0.7. Down, the probability is 0.2. Left, the probability is 0.1. It has a multiple 3 options with 3 different probabilities. This is the stochastic policy. The policy function is the mapping of the states and corresponding actions. These are either deterministic or stochastic. And in policy function, we are using optimal policy to get the maximum rewards. Okay, optimal policy gives the strategy that maximize rewards. In a policy with the maximize rewards. That is the policy function indicated with optimal policy indicated with pi star is equal to argmax of expected rewards of expected rewards of on a policy pi. It gives the strategy that maximizes rewards. If we know the expected reward for following any possible policy pi, the optimal policy represented to pi star is a policy that when followed produces the maximum possible rewards. Here argmax gives the select the maximum value on that on the rewards of the policy. So optimal policy gives the best maximizes rewards. For example, in self-driving car system, optimal policy is the best speed and direction to maximize safety and minimize the time. If the car needs to stop at the red light, the optimal policy would instruct the car to stop. The game of the chess, optimal policy would be the strategy that constantly wins against any opponent. That is the optimal policy. An agent following the optimal policy in chess might sacrifice a pawn in some state or some situation to win the game finally in a later state. It maximizes its cumulative reward. So optimal policy is to maximize the rewards. We are indicating the optimal policy with the pi star. In the grid world example, to reach the bottom right corner is the goal state, while avoiding the obstacles optimal policy. We are at the state 2, 3. We are going down 3, 3. That is the best optimal solution, optimal solution. Okay, instead of choosing another, we are going move down to the 3.3. That is the optimal policy. Next one is in optimal policy, we are find the best rewards. We are maximize the rewards by using optimal policy. These optimal policies we are using to train the agents to get the best cumulative rewards. There are the 2 ways we are train our agents. That is the directly training and another one is indirectly training. In directly, we can teach the agent to learn what actions are best in a given state. That is the direct method. Indirectly method, we can teach the agent to learn which states are most valuable and then to take actions they lead to the most valuable states. That is the indirect state. So what states are valuable and then what actions are best to move to the best states. That is the indirect training, indirect teaching one. Okay, the indirectly method leads to the value functions to get the best cumulative rewards. In indirect method, we are using value functions and q value functions. Okay, in the value function also called a state value function. This is indicated with the V. The state value function measures how good it is for an agent to be in a particular state. The state value function or value function measures how good it is for an agent to be in a particular state on a particular policy. Okay, for example, we are navigating the grid world game. If the agent is only 1 step away from the treasure, the state value of that position would be higher. Why it is close to the treasure point. So when you reach the treasure, we get the best reward. If the agent is 10 steps away from the treasure, the state value of that position is lower value. That is the less value. It is very far to the treasure position. Next one more example, in a game of the chess, the state value of board position could represent how favorable the position is for winning the game. So if your checkmate position would have the very high value, and while being on verge of losing would have the very low value. State value give the measure how good it is for an agent to be in a particular state. Okay, we are calculate that one using V value function of the state on a particular policy is equal expected reward of the state in a particular policy. The value function V phi is a function that maps a state S to the expected rewards. Okay, given that we start in a state S and follow some policy phi. Okay, it is a mapping function from state and rewards. The next one is Q function. The Q function also called a action value function. The Q function is called a action value function. It measures how good it is for the agent to take a specific action in a particular state. Okay, it is measured how good an agent take an action in a particular state. It is measured by using action value function or Q value function. This is measure the Q phi state on a action. This is mapping with the expected reward of the action on the state S on policy pi. Q pi is the function that maps the pair of states and action to the expected reward of taking action in a state S. Okay, here example, grid world game example, the agent one step away from the treasure. He has the two actions. One is move left and move right. So move, if the move right takes the agent directly to the treasure, the action value of the Q, the state S, move right action, it has a higher value. So it is plus 10. Move left takes away from the treasure. So action value of QS move left is equal to lower value, that is plus 3. In self-driving car, the action value for a particular, when it reaches the traffic light that is about to turn red, the action value of applying the brakes, the Q, the state of brake action might be the higher when it stop the vehicle to avoid the fines and accident. Action value of the accelerating, the action is accelerating, the Q value of state action accelerating will be low. So we say it crossed the red light. So this is the Q value function measures how good it is for the agent to take a specific action in a particular state. Okay, the thoroughly we are conclude the what are the policy function, what the optimal policy, what the value function, what the Q value function. The policy function maps the state and action. So it decides the what actions to take. It is get the pi of S. Optimal policy pi star S. It maximizes the rewards. Value function, it is also called the state value function, how good it is to be in a state. Q value function, it is also called a value action value function, Q of S comma A, state and action, how good it is to take a specific action in a state. Okay, these all are functions, policy function, value function, Q value function, these all are predict the future rewards in order to get the maximum rewards in maximum cumulative rewards in reinforcement learning. Thank you.